Hello, ladies and gentlemen. Root Beer here with another math contest, specifically the 2011 Galois contest. For those of you who've never written a Galois before, of course, you can click the link in the description below to go to the CEMC website and get a copy of this particular one, 2011 Galois contest. It's the grade 10 written solution contest put out by the University of Waterloo, as opposed to the Cayley, which is the grade 10 multiple choice, so you just need your final answer contest. So we're going to be going through, we're going to be writing up solutions to this particular contest, and yeah, not a whole lot else to say. It's like every other Galois, Friar, and Hypatia. 4 questions, written solutions are required for everything, and yeah. So again, click the link in the description, get a copy of this for yourself, and try it. Pause the video and try it because you learn so much more if you try the contest questions before just watching me go through them. Math is not a spectator sport, as one of my favorite teachers always used to say. But with going into any more preamble, let's just dive right into one of the questions. So we'll start with question 1, very appropriate. Jackson gave the following rule to create sequences. If x is a term in your sequence, then the next term in your sequence is 1 over 1 minus x. For example, Mary starts her sequence with the number 3. So to get the next term in her sequence, she needs to do 1 over 1 minus 3. So that becomes 1 over negative 2, which is negative 1/2. And now she has 3 and negative 1/2. To get the next term, well, she just takes negative 1/2 as her x and plugs it into 1 over 1 minus x. And when she does that, she gets 2/3. And if she continues on, then the next one, the 4th term in her sequence, comes all the way back to 3. Her sequence is probably just going to repeat after this. Okay. Fabian, let's say, starts his sequence with the number 2 and continues using Jackson's rule until the sequence has 2011 terms. So question A, what is the second term of the sequence? Okay, they're getting us accustomed to how the sequence works. We've seen examples of how it works for Mary. Now we're being asked to compute just the second term of the sequence. And if we look ahead at B, what is the 5th term of the sequence? Well, we can knock both of these out and also gain a little information on how this pattern works by writing out the first, the 2nd, 3rd, 4th, 5th. We can probably do a few more terms of the sequence. Okay, so let's get cracking. We'll bust out our notepad. So our first term is 2. To get our second term, well, we have to do 1 over 1 minus 2, which is 1 over negative 1, which is just going to be negative 1. So that would answer part A, but we're just going to keep going. To get the third term, we do 1 over 1 minus the previous term, which is negative 1. And that becomes 1 over 2. And not a whole lot else to say there. How about that 4th term? 1 over 1 minus 1/2. Well, what's 1 minus 1/2? Well, it's just 1/2. And 1 over a number is just that original number. So we're back to 2. So the 5th term is 1 over 1 minus the previous one, which is 2. Well, we already saw this. This is negative 1. And if we keep going, the 6th term is just going to be 1/2. Because when we plug negative 1 into the formula, we get out 1/2, and then we get out 2, and then we get out negative 1. So the sequence that we're looking at So we've got this, and this answer is A, and this answer is B. So I'll just make a little note of that, because we don't have anywhere in our exam booklet to put them, because we don't have an exam booklet. So that deals with A and B, and we understand the sequence a little better. It's just going to repeat over and over again. So we're asked, C, how many of the 2011 terms in Fabian's sequence are equal to 2? Okay. We also have determined the sum of all the terms in his sequence, remembering that his term only goes to 2011 terms, or his sequence only goes to 2011 terms. So, well, let's see. Look, our cycle repeats every 3. We go 2, -1, a half, 2, -1, a half, 2. So every third term is 2, but we need to explain that a little better. So the first term, so we make a note of the pattern that we see. The first term is 2. The fourth, now I'm just isolating where the 2's are. And if I look at this in terms of repeating 3's, I should start thinking about multiples of 3. Notice that every multiple of 3, 6, 9, is a half. So every multiple of 3 plus 1 is 2. So we can write that all nice, neat, and fancy as saying the 3n plus first term okay. So the 3n plus first term is 2. So this tells us a general formula for where our terms are going to be 2. Now, we have to figure out exactly how to count how many of them there are. We have 2011 sequence terms. It might be a good idea to see how many times this 3-term sequence repeats itself. So when we divide 2011 by 3, we get 670 with a remainder of 1. That's how I was always taught to do it, remainder of 1 like that. So since we have a remainder of 1, well, this is one of those numbers that is of the form 3n plus 1. So the 2011th term will be 2. So if we look at our terms, we could have the 2007th, 2008th, 2009th, 2010th, and 2011th. We'll have, that'll be a half, 2, -1, a half, 2. So the cycle has repeated itself 670 times before this point. So we'll have 672s plus the 2 at term 211. So we'll have 671 2's in the sequence. Okay. And now D part, I think it was add up all the terms in the sequence. Yeah, determine the sum of all the zeros in his sequence. Okay. Well, fortunately, in C part, we did a little legwork. We found out that there are 670 copies of that 2, -1, 1/2 sort of cycle. We noted that that just repeats and repeats. So if we could figure out the sum of one set of those 3 terms, then we multiply it by 670, and then we've got this one little 2 left on the end. We should be able to get the sum of everything. Okay? So that's our attack plan. Now let's see it in action. So the sum is 670 times 2 plus -1 plus 1/2 plus 2. Well, we can really quickly simplify this. 2 plus -1 is just 2 minus 1 plus 1/2, 1.5. And we have to remember to add on that last 2, that 2011th term. Well, 1.5 times 670. Again, you can grab your calculator because calculators are allowed on this contest. So we have 1005, and then we still have to add on that last 2. So we get a final answer of 1007. And if you wanted to, you could put a little therefore statement. So we have an answer of 1007. All right. So nice beginning question. We were introduced to a sequence. We were shown how it works. Then we showed that we understand how it works with the very first 2 questions. And then we did a little bit of calculation. We noticed a pattern. And we exploited that pattern not only to answer C, and figure out how many terms are equal to 2, but we also were then able to very quickly sum up the whole sequence. So a good starting question, and join me in the next video for question number 2 on the 2011 Galois paper. So until then, thank you guys so much for watching, and see you next video.